name is Jessica Kendall, and I'm a fifth-year PhD student in ecology and evolutionary biology, working with Dan Costa and Terry Williams at UC Santa Cruz. When you go to sleep and you return to the safety of your bed, do you ever wonder about animals floating in the open ocean with nowhere to hide? The second that you close your eyes, the chatter of your brain becomes louder and slower. Your neurons sync up to create large, slow waves during deep sleep. Throughout the night, your brain starts buzzing again. Your body becomes paralyzed, your eyes dart back and forth, and your heartbeat becomes erratic. Those two states, slow wave sleep and REM sleep, provide your body with different and critical restorative functions. Disruptions to that pattern, like insomnia, shift work, and sleep apnea, are chronic and pervasive, causing severe health issues around the world. But I know of an extreme shift worker called the northern elephant seal, whose healthy default is to stop breathing in order to sleep. By studying animals with extreme sleep patterns like these, we can learn more about the function and evolution of sleep. For my PhD, I set out with the question, how do marine mammals survive and sleep at sea? There was a problem, though. Previous studies of sleep with marine mammals, all done in captivity, used implanted electrodes secured to the skull or that pierced the skin. I was told that it was impossible to measure these signals any other way, especially across the thick blubber layer of a northern elephant seal. Determined to create a gentler method, I spent the next 3 years refining and fine-tuning this non-invasive, surface-mounted sleep recording device. I learned electrical and material engineering skills, soldered hundreds of wires, and tested over 25 brands of adhesive. We recorded sleep on land and in shallow water, at the Long Marine Lab and in the wild, on the beach and in shallow lagoons at Año Nuevo, and finally, at sea, on the continental shelf and out in the open ocean. Seals slept almost half the day while on land, whether in the lab or in the wild, but while at sea, they need to feed around the clock to support their large body mass. This constrained sleep down to less than 2 hours a day over multiple days in the open ocean, lower even than the current record set by African elephants. Still, to understand sleep at sea, I needed one more tool. I built a custom 3D animation pipeline to recreate, based on the sensor data, the movement and behavior of the seal. I saw that she fell asleep 5 minutes before she turns upside down. Then, and only once, the sleep paralysis of REM takes over, she loses control of her posture, turns upside down, spins in a circle, floating like a falling leaf. Next time, when you're safe in your bed, imagine all the sleeping seals surrendering to the deep as they drift down while their predators circle overhead.